why do we age? Where is it originating? So we see aging at different levels. So the way I like to look at it, we call it, as a scientist, we say at the phenotypic level, this is essentially what you see on the surface. So again, you might be familiar with some of these. You see reduced gait, which is the speed at which you walk tends to become slower as you get older. Reduced strength, so meaning you might not be able to grip things as well when you get older. Increased frailty, so you become frail and you become, there's a lot of loss of muscle mass as you get older. Increased visceral fat, this is something that a lot of us have a problem with. There's, especially around midlife, you tend to accumulate a lot of abdominal fat, right? And this is also a function of aging, as research is sort of starting to show. And then we also see reduced memory. We talked about cognitive decline. There's reduced decision to reaction time. So you might see something, the time that it takes for you to react to that can be longer in older adults. And then there's also reduced visual perception. So your depth perception might change as you get older. And then collectively, this really leads to a lot of functional deficit, and you might not be able to do the same things that you once were able to do when you were younger. Now, what's really exciting is that a lot of these changes that you see on the surface is driven or preceded by changes that happen at the cellular level. So this is driven by changes that are happening in your cells. And there are what we call hallmarks of aging. There's more than a dozen right now as of 2023. And I've listed a few here. So these are changes that are happening inside your cells that really drives these changes that happen on the surface. So this includes things like genomic instability. We talked about genetics earlier. So what genomic instability means that your genome becomes unstable as you get older. And then also your telomeres, the ends of your chromosomes, if you're familiar with biology, those sort of act as these protective caps for your genome, and they tend to get shorter as you get older. And then there are many others as well. Your metabolism slows down, the way you process nutrients changes, and many things that are happening at the cellular level that ultimately gives rise to these changes at the global phenotypic level. So what really happens with aging is that there are many things. The simplest way to think of it is it's a breakdown of your system as you get older, for a variety of different reasons. So it could be due to repeated chronic exposures, accumulation of cellular damage, loss of cellular defenses, and also impaired resilience and recovery. Okay, so you're well at one point when you're younger, but due to certain accumulations and not being able to recover from these accumulations, your systems essentially break down. Your cells, your organs, and also like your function. Now, what happens is, as you get older, the probability of developing chronic diseases goes up. We talked about this earlier. So this happens during average aging. So we're all going to age, no matter what you do, we're going to age in a certain trajectory. But what research and what science is actually showing us is that there's a way to sort of perturb or move that a little bit towards a healthy aging trajectory. What can you get by doing that? You can actually reduce the probability of developing these chronic diseases if you do follow a healthy aging trajectory.